Hello dear students of plus 2 medical, non-medical, respected teachers and dear friends. Today I am going to discuss the topic half-life or average life or mean life of a radioactive element. So first of all, what does it mean by half-life of a radioactive element? Since radioactivity is a spontaneous process in which there is continuous emission of alpha beta particles without depending upon external conditions like temperature, pressure. So the time during which half of the sample decays, or time during which half of the number of atoms decays and only half number of atoms are left undecayed, is known as half-life of the radioactive element. So, according to definition of half-life, when t is equal to t half, that is when time is equal to half-life, then n becomes n naught by 2, where n naught is the initial number of atoms at t is equal to 0 and n is the number of atoms present at time t. Then according to radioactive decay law, n is equal to n naught e raised to minus lambda t, because this decay is exponential. So at t is equal to t half, put n is equal to n naught by 2 in this equation number 1. So we have n naught by 2 is equal to n naught e raised to minus lambda t half. So this n naught cancels. So from this we have e raised to lambda plus lambda t half is equal to 2. Taking reciprocal on both sides. Then taking log on both sides, we have log e raised to lambda t half to the base e is equal to log 2 to the base e. Since log m power n is equal to n log m, so therefore we have lambda t half is equal to log e to the base e is equal to 2.303 into log 2 to the base 10. So log e to the base e is 1. Therefore we have lambda t half is equal to 2.303 into 10 into 0.3010, which is the value of log 2 to the base 10 from log tables. If we simplify it, so we get t half is equal to 0.6931 upon lambda, which is required expression for half-life of a radioactive element. It means half-life of radioactive element depends upon decay constant lambda. Now, at t is equal to t half, we have said n is equal to half of n naught. After next half-life, that is after two half-lives, n will be equal to half n naught by 2, that is n naught by 4 or n naught into 1 by 2 power n. After three half-lives, similarly, n will be equal to n naught 1 by 2 power 3 and so on. After n half-lives, n will be equal to n naught into 1 by 2 power n, or n upon n naught is equal to 1 by 2 power n is equal to 1 by 2 power t upon t half, because total time t is equal to n into t half. So using this expression we can find number of half-lives if total time is given, or if number of half-lives are given, total time is given, we can find half-life. So this expression is used for numericals purpose. So then we come to average life or mean life. It is understood average life means it is defined as the ratio of total life of all the atoms in the element, in the sample of the element. So ratio of total life of all the atoms in the sample of the element to the total number of atoms present initially, that is at t is equal to 0. Now, suppose dn is equal to small number of atoms which decay during small time dt. Then all these atoms will have half time life between t and t plus dt. So we can take average age of each dn atom average age of each of dn atoms which decay during time dt is equal to t. The total age of dn atoms will be equal to t into dn. So because the decay between t and t plus dt, small time interval, and total age or total life of all the dn atoms which decay during time dt will be equal to t into dn. The total life of all atoms in the sample will be equal to integral 0 to n naught t dn. When whole of the atom will decay, total life will be t dn 0 to n naught. This is the total life of all the elements, all the atoms in the sample of the element. Therefore, by definition from this equation, t array will be equal to 0 to n naught t dn upon n naught, which is the equation number 4. To solve it, again we use radioactive decay law, which is given by n is equal to n naught e raised to minus lambda t. Now differentiating it, we have dn upon dt, n naught constant as such, e raised to lambda minus lambda t, d by dt will be minus lambda n naught e raised to minus lambda t, or it will be dn is equal to minus lambda n naught e raised to minus lambda t dt. So substitute the value of dn in this equation number 4. So we have t a, average half life, average life or mean life of radioactive element is equal to 1 upon n naught integral. No, integral instead of 0 to n naught we have infinity to 0, because t is equal to 0 correspond to n is equal to n naught, and t is equal to infinity correspond to n is equal to 0. So limits will be infinity to 0 instead of 0 to n naught, because now we are integrating with respect to t. So it will be t lambda n naught e raised to minus lambda t dt. N naught cancels, or t average comes out to lambda can take outside integration, or this minus sign can be replaced by taking integration 0 to infinity instead of infinity to 0. So we have t average equal to lambda 0 to infinity, reverse the limits, negative sign is absorbed. So lambda 0 to infinity t e raised to minus lambda t dt. Now this is a product of two functions. Now we have to integrate it by parts. So integrating this equation by parts, this is first function, this is second function. So t array is given by lambda. Now integrate, we have first function as such t, then integral of e raised to minus lambda t, that will be e raised to minus lambda t upon minus lambda dt. There will be no dt. 0 to infinity limits minus integral 0 to infinity, 0 to infinity. Now d by dt of t, which is 1, and integral of 0 to infinity e raised to minus lambda dt, that will be e raised to minus lambda t upon minus lambda again dt. So we have to integrate 0 to infinity this whole function now. Now this factor will be 0, because e raised to minus infinity, it will be 1 upon e raised to infinity, which is 0. Anything divided by infinity is 0, so it will be 0. This integration comes out to be 0. Minus minus plus, so plus 1 by lambda. So limits will be 0 to infinity e raised to minus lambda t dt. Again, so we have lambda cancels, so 0 to infinity e raised to minus lambda t dt. Integration will be e raised to minus lambda t upon minus lambda. Put upper limit infinity to, then lower limit 0, it will be 0 minus 1 upon minus lambda. So this cancels, or we have 1 by lambda only, because anything e raised plus 0 is 1 and e raised to minus infinity is 0. So it comes out to be t average is equal to 1 upon lambda. It means average life or mean life is defined as the reciprocal of decay constant or disintegration constant. Now if we have to compare average life with half life, so as t average equal to 1 by lambda, and from this equation we can put the value of 1 by lambda T half on 0.6931 in this question. So T average is equal to T half on 0.6931. So it comes out to be 1.44 into T half. It means average life of a radioactive element is equal to 1.44 times its half-life. So this is the required relation between half-life and average life. So this is all about half-life and average life of a radioactive element. So all the best, be happy, good luck, stay tuned for next video, and you can check the videos on my YouTube channel, and I have uploaded almost all the topics of plus 1 and plus 2, even 9th and 10th class. So you can check and learn by watching these videos. All the best, good luck, thank you.